Good morning and welcome to Tech 240 on Wednesday, February 10th. The purpose of today's video is to do a bit of review of the material we've covered so far in preparation for Exam 1. So before we talk about that material, let's take a look at the schedule and see what due dates we have coming up. So first of all, we have Lab 6 due today, February 10th by 11:55 p.m. on ReggieNet. And then we also have Lab 7 coming up. It's due on February 14th. That's this Sunday. Normally, I almost always give you exactly a week to complete the labs, but Lab 7, you have just under a week. And the reason for that is I want you to do Lab 7 before you take Exam 1 for your own benefit. I think it will help you if you do Lab 7 and have a good grasp of those concepts before taking Exam 1. All right, so Lab 7 is the last lab in the first third of this class. And then we have our first exam on February 15th. That's next Monday. So the way I will schedule Exam 1 is I will have ReggieNet open up the exam at 12 o'clock a.m. first thing on Monday morning, February 15th. And then it will remain open for the full day. So there's a window of, I guess, 23 hours and 55 minutes because I'll set it to close at 11:55 p.m. on February 15th. And there will be a time limit of 3 hours. So you can pick any 3-hour window in that day on February 15th to take the exam. So I will set a time limit of 3 hours. I think that should be plenty of time. I will write the exam kind of the same way as I write the exams normally when I teach Tech 240 in person. So I will write it such that I think it should be able to be done in an hour and 50 minutes. So you'll have an extra hour to do it. So you shouldn't be in a big rush. That being said, you're not going to have time to go back and reread the material or anything. So you need to be comfortable with the material before you take the exam. But assuming that you've done all the lab assignments and you're comfortable with them and you've watched the videos and paid attention and everything, I think you should have plenty of time without being too terribly rushed. All right, so that's the schedule. It'll open at 12 o'clock a.m. on February 15th, and it'll close at 11:55 p.m. that same day, later that night. Just pick one 3-hour window in there to set aside and sit down and take the exam. All right. Content. Let's start with structure. Let's start with the structure of the exam. The structure of the exam, it'll be a mixture of things. There will definitely be some multiple choice and maybe some matching. I might put some matching in there with different schematics or something like that. Some of the material will be covered in a matching format, and then there will definitely be some calculations as well. We've been doing calculations on every single lab 1 through lab 7. So I will make sure some of that material appears on the exam in the form of calculation problems. The calculation problems will probably be a numeric response where I will show you maybe a circuit, or I'll describe the circuit, and then you'll have to do some calculation to calculate the voltage drop or the current flow or something like the resistance value, something like that. And then after you calculate it, you'll have to enter the value in volts or amps or ohms or something like that. And I will set ReggieNet so that there is a range of correct answers. So if the correct answer is 12 volts and you enter 11.9, that's close enough, because I will make sure that the range of acceptable correct answers is wide enough to account for some rounding error, like we've talked about so far in the class. What I'd probably recommend you do, and I think I've mentioned this before, is when you're doing these calculation problems, as you're doing the problem, like in the intermediate steps in the problem, keep a few more sig figs, keep like maybe 4 or 5 significant figures as you're doing the problem. And then at the end, you can round to, it depends, but the nearest ohm or the nearest. It depends on the type of problem, and I'll try to be specific of how you should round the problem. But as long as you're within, in general, I'd say within 5 or 10%. I'll have to look at each problem and determine what is an acceptable range of answers. But I'll try to be generous, and it'll be within 5-10%, something like that. So don't think that if the answer is 12 volts and you put 12.1 or 11.9, you'll get it wrong. No, I'll make sure that there's a fairly wide range where if you're doing the problem correctly, you should get an answer that is within that range. In terms of what resources you can use while doing the exam, you can use pretty much any of the course content. You can use the lab manual. You can use your calculator. You're going to need to use your calculator, actually. You can use the videos that I've been making. You can use your labs. You can use pretty much anything, except, like I said on the first day of class, you can't use each other. So I don't want you texting back and forth and saying, hey, what'd you get for number 13 or something like that. So you can use pretty much any of the course materials except each other. You can't take this as a group exam. And, a lot of times students think that it's very difficult to determine if there's been academic dishonesty, but it really isn't that difficult. And the reason that is because RegiNet provides the instructor with a lot of information. I'll have information about when you start the exam, when you finish the exam, obviously all your answers, what time you entered each specific answer. So there's a lot of information. So it's not really that difficult to determine if two people were working together on the exam, because they're going to be answering questions at the same time and the same answers and so on and so forth. So don't attempt that, and we won't have to go down that road, because that's not a fun road to go down for me or for you. So we'll try not to do that. Sometimes I'm asked for my recommendations on what it is you should study. And for that, I usually say, well, there's kind of two different types of questions on this exam, but also in this class. And the first type of question is more of like a conceptual or qualitative question, like where we've got two components in there in parallel. What can you tell me about the voltage drop? That's a conceptual question that I could ask you in a qualitative manner. I could ask it as a calculation question too, but it could be posed as a qualitative question. So for those kind of conceptual or qualitative questions, the places that I'd recommend studying to make sure that you're catching all of those are the lecture videos, your lecture notes, and maybe the PowerPoint slides that I gave you at the beginning of the semester, and the reading assignments, especially the reading assignments from the lab manual. So make sure you have read all of those reading assignments from the lab manual. The other type of question that I'm going to ask you in this exam and in the whole class as a whole are more like calculation questions, like quantitative questions. And for those types of questions, the best things to review are your labs, because those are the things that I think are important, obviously, because I put them in the labs. So I will try to put questions in the exam that relate to each of the labs. We've had 7 labs so far in the class, so there will probably be at least some material in the exam from each of the 7 labs that we've done in the class so far. If you're looking for additional calculation review type problems, we've got the circuit calculation practice worksheet that starts on page 31 and goes through page 33 in the lab manual. And then we also have some more review problems that are after lab 7 in the lab manual, from page 55 to page 57. Those are some more review problems that would help you as you're preparing for exam 1. And I will make sure those answer keys to those example problems, the review problems, are on RegiNet. All right, so I think that pretty much covers the schedule and the format of the exam. Now let's go ahead and talk about what content material is going to be on the exam. So to do that, I'm going to switch over to my document cam and I'll write some of this stuff out. All right, so for Exam 1 topics. Exam 1 topics. All right, well, one of the first things we talked about in the class was electrical fundamentals. For example, what is charge and current and voltage and resistance? You should have a pretty good grasp of those different concepts of electricity fundamentals, what each of those things are. We also talked a little bit about how to make a complete circuit. You got to have a path for charge to flow, or in other words, a path for current to flow. You also have to have a voltage source. That's what provides the impetus to actually force that charge or current to flow inside the circuit. We also spent some time talking about electrical safety. And we talked about such topics as the minimum lethal voltage and how we did that calculation. What are some reasonable assumptions to do that calculation? And we talked about how electricity can hurt you. There are two main mechanisms by which electricity can hurt you. And we talked about some methods for how to work safely with electricity. There were at least a dozen or so. How to work safely with electricity. At least a dozen or so practices that you can use to protect yourself while you're working with electricity. And I would also categorize the lotto system. That is part of electrical safety because it's how you work safely with electricity. And you should know what it is, what does lotto stand for, what it is, its purpose, why we use the lotto system, and then some key things in there. We had the 9 steps. So you should be familiar with these. Again, I would not ask you an essay question that's like, describe all 9 steps of the lotto system, because that, frankly, would be terrible to grade for me. So I'm not going to ask you that. But you should be able to put the lotto steps in order, and you should be able to describe each of those steps. For example, one of the really important ones is called the hot, cold, hot check. That's a check that I do when I'm working with electricity at home every single time, whether I'm working on a light switch or an electrical outlet or working in a lab with electricity. It's important to do a hot, cold, hot check. Also, some concepts were the number of keys per lock. How many keys should there be for each lock? And the number of people per lock. In other words, if I gave you a question like, all right, there are 2 people that are, you should be able to do a problem like this. There are 2 people that are working on a piece of equipment, and this equipment, in order to isolate this piece of equipment, there are 3 circuit breakers that need to be locked in the off position. So how many locks total am I going to need for that work, that piece of maintenance or whatever it is? You should be able to answer that question for how many locks you need. All right, so that's the overview of the lotto system. And then we talked about resistance in series and parallel circuits. This was lab 1. Just calculating the total resistance for resistors that are in series and parallel. And we talked about voltage and current in series and parallel circuits. So you should know how the voltage across components, how to calculate that for circuits that are either series circuits or parallel circuits or some combination of series and parallel. And to do those calculations, we talked about using Ohm's law, and we also talked about voltage divider. So I might come up with a question that you have to use voltage divider in order to calculate something. Maybe there's not enough information to use Ohm's law, but you can solve it with voltage divider. So make sure you're comfortable using either one of these methods. And then we moved on to solving more complex circuits, And the tools that we used to solve those were KVL and KCL. And this is about as complicated as we're going to get. I will always make sure, if I'm giving you a circuit to solve, there is always a way to solve the circuit using some combination of Ohm's law, voltage divider, KVL, and KCL. And specifically with KVL and KCL, there will always be an equation that you can write where there is one equation and one unknown variable. That unknown variable could be a voltage drop or it could be a current through a component, but there will always be a way to write an equation to solve for one unknown variable with one unknown equation. In general, in the real world, that's not always true, and I think I mentioned this while we were talking about this. In the real world, there are circuits, there are plenty of examples of circuits where you can't write one equation with one unknown. You might be able to write two equations with two unknowns in them, or three equations with three unknowns in them, and then you have to resort to solving the equations simultaneously using some various different tools that you may have learned about in your math classes. But at that point, it's a math problem. And so we're not gonna go any more complicated than this, where there will at most be one unknown variable with one equation to solve, to find that unknown variable. All right. Yeah, also, I guess I could put another tool is to find equivalent or R total. So maybe that should come up here. I don't know, but make sure you can find the total resistance or equivalent resistances for resistances that are in series or parallel. That's kind of another method of solving these problems. And the next step was lab 4, where we talked about power and energy in electrical circuits. Remember, power in the electrical domain is equal to current through the component times voltage drop across the component, and energy is equal to the power times the length of time. Keep in mind your units here. I often see mistakes in the energy calculations. So make sure that your units for practical purposes in this class or in the electrical domain, your units for energy are usually going to be watt hours, kilowatt hours, megawatt hours, something like that. You could convert that into joules, but that's usually not done in practical cases. And what next? Then we started talking about ladder electrical diagrams. You should be able to interpret ladder electrical diagrams that I give you and talk about what's going to happen, say, when I just connect the ladder electrical diagram, but before I press any buttons, and then what's going to happen when I press, say, the start push button or the stop push button or push button A, things like that. And we talked about relays. Relays are a really important and very practical topic. So with regards to relays, you should know what they are and how they operate. Operation. of relays, what they are and how they do it, and the purposes. We talked about 4 very common reasons that you might use a relay. So 4 purposes for a relay. And we talked about relay logic. There are kind of 6 of these. One is so basic it doesn't even really have a name, which is when the relay coil is energized and it makes a connection. That one's almost so basic it doesn't have a name, but the other 5 do. The other 5 are not logic, and, or, NAND, and NOR logic. So you should be familiar with all of these logic functions of a relay and how to create those circuits and how to interpret them. Going along with relay logic, we have truth tables, sometimes called logic tables. Truth tables. So if I give you a lateral electrical diagram, then you should be able to fill in a truth table with basically what's the output going to be for various combination of inputs. And we're almost done. We talked about, I kind of skipped over this. We talked about LEDs. And we talked about how they operate. Oh, and you know what? We talked about diodes too, which are very similar, but they're 2 different things. Diodes, how they operate, and p-in junction is an important topic with regards to diodes, as well as band gaps. What is the band gap? Those are important topics for diodes. What they are, how they operate, what is the p-in junction, what is the band gap. So LEDs kind of have the same types of things because they basically are just special kinds of diodes. And for LEDs specifically, we talked about how to build circuits with LEDs and how to calculate the size of the protective resistor. Calculating protective resistance in series. So that's our protective series resistance. And you got some practice in lab 5 calculating the value of that series protective resistance. All right, and one more thing that I'm trying to remember. We talked about latching circuits. I haven't mentioned that yet. That was lab 6, I believe. So designing and building latching circuits, designing a lateral electrical diagram to utilize a latching circuit, and then also interpreting latching circuits. If I gave you a lateral electrical diagram, you should be able to recognize a latching circuit and explain how it operates. All right. I guess I'll add Tinkercad. And we use Tinkercad for most of the labs. You know, I'm not gonna have you get into Tinkercad and design a circuit in Tinkercad, but I might see if I could be creative about maybe I will design a circuit in Tinkercad and then show you a picture of that circuit in Tinkercad, and then you might have to explain to me how that circuit operates or what happens when I press the push button or switch the slide switch or something like that. So I'm going to try to integrate Tinkercad somehow into the exam, even though I'm not going to have you go into Tinkercad and design a circuit for me. All right, I don't guarantee that that is a 100% comprehensive list of topics that we've talked about in this class, but I think it's pretty close. It's just about everything that I can think of off the top of my head that we've talked about in this class. So if you feel comfortable with all of those topics, you should be pretty well set up for exam 1. All right, don't forget about the review worksheets that start on page 31 and page 55. Those answer keys are posted on Reginet so that you can check those and see how well you're doing on those worksheets. If you have any questions, please let me know. I've got office hours on Thursday, so feel free to come to those, and I'd be happy to answer any questions, work through any problems, clear anything up that might still be fuzzy in your head. So take advantage of those if you want to. Otherwise, the next time I'll see you is after exam 1, when we're going to start a totally different topic. If you didn't like the material that we talked about in the first third of TEC 240, don't worry, you're in luck, because the material in the second third is pretty much totally different. It's about electric machines like motors and generators and things. So when we get back together after exam 1, the first thing we'll talk about is magnetism and electromagnetism. So I'll see you after exam 1. Good luck on exam 1, and I'll see you next time.